and cotangent look very similar. They're just shifted over a little bit. So if we look at, for example, I'm not going to fill out the table. I guess what I'd like to do is I'd like to look at the tangent and kind of see how it looks as a general rule. First of all, the difference between tangent and cotangent versus sine and cosine. In sine and cosine, the period was 2 pi. But in tangent and cotangent, we're going to have periods of pi. That means from the beginning to the end, you will see one full sequence of the tangent graph within 1 pi. So for tangent, when you look at what's going on there, what you'll see is that the normal tangent curve goes between pi over 2 and negative pi over 2. So this is what the tangent looks like. And there will be an asymptote here and here. And these asymptotes are going to be located at negative pi over 2 and positive pi over 2. And the space between negative pi over 2 and positive pi over 2 is 1 full pi. That's how they get the pi for the period. Don't forget that this graph continues on forever. So I can keep going and I will see this same graph repeated again and again and again because this is a continuous graph. It goes on forever. It's periodic. So then if I add another pi onto pi over 2, the next asymptote would be located at, no, 3 pi over 2. So you better make sure you figure out how to add pi on to each other. Remember, you have to have a common denominator to do that. So pi is like 2 pi over 2, 1 pi over 2, and 2 pi over 2 makes a total 3 pi over 2. And this starts that thing. I'm not really worried about that. So what I want to see on your graph is at least one full period. And with the tangent and the cotangent, I want to see the asymptotes as well and where they're located. So that's what I'm looking for. Tangents and cotangents do not have amplitudes. They do not have amplitudes because they go on forever up and they go on forever down. So in the positive y direction and negative y direction. So we do not talk about amplitudes with tangent and cotangent. I would write myself a note. The second graph that we're going to talk about is the cotangent. It looks very similar to the tangent graph. There are two main differences. The first main difference is that the cotangent graph, instead of going up to the right, goes down to the right. So it looks like this. And the second difference is that its period, which is also pi, is going to fall between 0 and pi instead of negative pi over 2 to positive pi over 2. So it's been shifted to the right pi over 2 and flipped. The period is still pi. We're not going to talk about starts at. On a test, I would be looking for the asymptote locations with the markings on the x-axis, as well as a picture of the graph. So tangent and cotangent, I look for the graph itself and where the asymptotes are occurring. I would write that down. If you remember yesterday when we talked about sine graph, and I didn't go into extensive detail about cosine graph, I talked about 4 pieces, A, B, C, and D. These 4 pieces are going to be working with sines, cosines, tangents, cotangents, secants, and cosecants. So if you understand yesterday's last problem, that applies to all problems. Okay, how the midline moves, how we don't have an amplitude in tangent and cotangent, but how the period would be affected, all of that stuff. Okay, the only difference about the period in tangent and cotangent is that it's pi and not 2 pi. So as we look at this next page here, we see a chart. And you'll see those same kinds of equations that we talked about yesterday, the one with the tangent and the one with the cotangent, and they also have the A, the B, the C, and the D. Now the truth is the A in front of the tangent and the cotangent, just like it did for sine and cosine, does affect the stretching, but really you can't tell how much it's been stretched. It looks a little bit different. I'm not really worried about that in your graphs when you take your test. I'm looking again for the asymptotes and the overall picture of like where the middle of the tangent and cotangent shift. When you take your exams, there are going to be graphs that you have to create. 4 points out of the 6 points for those graphs are going to be based on writing down the the amplitude is whatever. The midline is whatever, the period is whatever, and the phase shift is whatever. I will remind you of this on test day and review day, but I'm just telling you 4 points on that part of the test will be based on those 4 things written down off to the side. Okay, and I'll tell you that again on test day and review day. The big idea is that don't forget the period for tangent and cotangent is equal to pi. This is different than the sine and the cosine. In the sine and the cosine, again, it was 2 pi. Now it's pi. And so yesterday I told you that if you're looking for the period, the new period, if it's been changed by the b, then you would have taken yesterday 2 pi divided by that b. Today, because the period is b, or is, pardon me, pi, you're going to divide pi by b, not 2 pi. And what I mean by that is this piece right here, if you're trying to find the period, take pi divided by the b. Everything else kind of works the same. So if you're looking for the phase shift, set the parentheses equal to 0. If you're looking for the period, take whatever the period normally is, pi or 2 pi, and divide by whatever's in front of the x. Same kind of thing. So let's try a couple. Oh, look. We have y equals tangent of 1/2 x. What is the only thing that has been changed compared to the normal tangent? Jessica? The period, because there's something in front of the x. So in order to find the period change, off to the side, those 4 things that I talked about, amplitude has not been affected at all. We just, for amplitude, are just going to put an x there because we don't really talk about amplitude with tangent or cotangent. The midline is equal to 0 because it's not been shifted up or down. The period is the thing that we want to talk about, and in order to find the period, I take pi and I divide it by whatever's in front of the x, which is 1/2. Bless you. So that would be a total of 2 pi. Very good, Jessica. 2 pi. And then the last thing is, was there a phase shift? Or in other words, was there a plus or minus inside of the equal sign? No. So then we just say none. There's no phase shift. So now if I want to draw this tangent graph, it looks the same as before. The only difference is when I draw my tangent graph this time, what I know is that these asymptotes are no longer at pi over 2 and negative pi over 2 because I've doubled the length of my period because I'm going half as fast. So this location is pi, and this location over here is negative pi because I went pi to the left and pi to the right. That's a total of 2 pi. Okay, cotangent is like tangent, but it's been reversed because it's now going down to the right. The 2 normally affects our amplitude, but as I told you, we don't really deal with amplitude. You'll see a slight stretching in the graph or an increasing of the rate, but the asymptotes don't change because of it, so we don't really worry about it, because when you try to draw things visually on your paper, it's really hard to depict that. So I don't really look for that, even though we know the rate is twice as much. So off to the side, I'm going to be writing down that my amplitude, I'm not going to talk about that. My midline is equal to 0 because nothing's changed. There is no phase shift, again, because there's no plus or minus in a parentheses. So really all I have to worry about is my period. So the period is divide whatever the normal period is by whatever's in front of the x. What's the normal period? Pi. So I take pi, and I divide it by whatever's in front of the x, which is pi. And I get 1. That means I'm going 1 unit total to draw my cotangent. So this is what my cotangent looks like. I know this, normally. There's going to be a center point here. And from one asymptote, because there was no phase shift, to the other asymptote, the total space there is 1, because that's the period. So here's a 1. So where's the center? 1/2. Notice how there's no pi involved? Weird. But that's what it is. I probably should do a different color for the numbers. Sorry, let me just change that. So this is a 1/2 here. This is a 1, and our period was 1. So you can just cross off letter C. That's really the same as the one we just got done with. We're not going to do this one. It'll be a waste of our time. Let's look at D. In D, we're dealing with cotangent. So this is the one that goes down to the right. And I know that I don't have to worry about this. We're just going to ignore that. Was there a midline change anywhere? Nope. No, there wasn't, because there's no plus or minus on the outside of the parentheses. So with amplitude off to the side, we know there's none. The midline is equal to 0 because I did not move up or down. Is there any number in front, directly in front of the x? Nope. So the period's going to be pi. But I noticed that there is a phase shift because there's a plus or minus inside of the parentheses. So it's negative pi over 2 because that is what makes the parentheses 0. Just like in sines and cosines, set the parentheses equal to 0. Or in other words, what makes the parentheses 0? That's how far it's shifted. So you know how normally what we would be doing for our graph, this is not the graph, but what we'd normally be doing for this cotangent graph would look like this. And we would have the center at pi over 2, right? And then it would go to pi. So this would be from 0 to pi. Now the real graph has been moved to the left pi over 2, because that's what negative pi over 2 means. So now it looks like this. And I have my asymptotes. And these locations are now pi over 2, because it used to be pi, and I went negative pi over 2 or left pi over 2, and then negative pi over 2. So now this looks like the tangent, but it's been flipped. All right, I'm going to draw something for you. I'm going to start with the cosecant graph. So let's look at this one first. We know that the cosecant is the reciprocal of
1 over
If
sine.
you can't answer this, that's a small problem, right?
1 over sine.
Joe.
1 over sine.
It's 1 over the sine of x. So in other words, it's the reciprocal of the sine. Now let me show you why I'm telling you that. Down below, in this cosecant graph that I'm going to do right now, I'm going to draw the sine graph. So just watch for a second. In the sine graph, we had 4 critical values that occurred at 0, pi over 2, pi, 3 pi over 2, and 2 pi, because the normal period for the sine was 2 pi. Don't draw, just watch. I'll give you time to draw, don't worry. And then we know that our amplitude was 1 in a normal sine graph. So when we graph this thing, this is what it would look like. And this is from yesterday. You guys remember that from yesterday?
Yeah.
Okay, so watch this. Watch how cool this is.
That's weird. So.
The red graph is the secant graph. I want you to draw what you see on the whiteboard and write yourself a note about how to graph the cosecant. Okay, so the way I think about this is I take the sine graph, I flip the mountain